Hey guys, welcome back. In today's video, I'm going to discuss strong induction. So we have to prove that every natural number n is greater than or equal to 24 can be represented as n equals 4x plus 9y for some x and y belongs to n. So let's start our proof by using k naught, which is our starting point, is equal to 24, and our last base case k1 is equal to 27. So let's write our inductive statement, which is P of n, and that is there exists an x but which belongs to our natural numbers, and there also exists a y which belongs to a natural numbers, such that 4x plus 9y is equal to n. So this is our inductive statement. So now let's prove and establish our four base cases. So we have n is equal to 24. When n is 24, 4x plus 9y should be equal to 24, and we have to find a combination of x and y that gives this value such that x and y are natural numbers. Setting x is equal to 6 and y is equal to 0 does this, as 4 times 6 plus 9 times 0 is equal to 24. So this works. So this base case is satisfied. Similarly, when n is equal to 25, we can do 4 times 4 plus 9 times 1, which is equal to 25. We found another combination, so this base case is also established. And finally, when n is equal to 26, actually not finally, this is our second last base case, we could do 4 times 2 plus 9 times 2, which is 26. This is established as well, and then n is equal to 27 would give 4 times 0 plus 9 times 3, which is equal to 27. So we found a combination of x and y where x and y belong to the natural numbers that give us these four base cases. So now that we're done with the base cases and the inductive statement, let's move on to the inductive hypotheses. So given k is greater than or equal to 27, let us assume pj is true for all 24 less than equal to j less than equal to k. In particular, this tells us that pk minus 3 is true, because we've seen that n equals 27 and n equals 24 is true, and 27 minus 3 is 24. So we can write this as k minus 3 is equal to 4x plus 9y for some x comma y belongs to n. So this is our inductive hypothesis. And finally, our inductive step. So we must argue pk plus 1 is true. That is, we must find a way to represent k plus 1 as a sum of 4s and 9s. Applying the inductive hypotheses, we have k plus 1. This can also be written as k minus 3 plus 4. And using the inductive hypotheses, we know that k minus 3 can be written as 4x plus 9y, because that's how we got this, plus 4. And this is equal to 4 times x plus 1 plus 9y. Since x is an integer, x plus 1 is also an integer. So we found a way to represent k plus 1 as 4 times an integer plus 9 times an integer. So p of k plus 1 is true. So by strong induction, we conclude that p of n is true for all n greater than or equal to 24. Thank you, and I hope you guys enjoyed today's video. If you have any questions, please make sure to drop it in the comment section below, and please like and subscribe. Thank you.